Hello. Alright, so I recorded a whole Code Plus Vibe Part 2, but as a continuation from the first Code Plus Vibe, I was having a lot of technical difficulties. I forgot to record the audio for my screen recordings. On top of it, my computer crashed and restarted in the middle of one of the recordings, so I lost one. It's just been a big whale of a time. So I think I'm just gonna scrap that video. And for this part 2, I'm just gonna go through the code that I added and explain what I did. And then we're just gonna move on and pretend all this never happened. But as always, thank you for watching. And let's take a look at some of the code that I added while I was struggling. So, as Lil B said, you know, everybody's struggling. You know I love struggling. I don't know what that means, but he did say that. So, alright, I got a better setup this time. Doing it all on OBS on Mac. Hopefully it works out. I don't know how great OBS works on Mac, but I did learn it's not great on Linux. So, let's hope that we get some better luck this time, because a bitch is trying to be a YouTuber. Let's see. So, what I worked on this time. Okay. Okay, so last video I left off after doing the arithmetic group and I did the branch group. So jumps, returns, calls, all that nonsense was implemented in the last video. In the footage that I lost, I added all the logical group. So logical operations include ands, ors, exclusive ors, not that kind of stuff. So to implement those, I created some helper functions, some stuff unrelated to that too. I created a helper function for getting the memory address to operate on, because I noticed I was grabbing that a lot. And that is just the contents of the H register and the L register appended to each other. So I have a helper function for getting that, and then after getting that offset, grabbing the chunk of memory at that offset. So for AND, it is pretty simple. You just AND the two registers together, whatever register has been passed in. For OR, same thing. And then we update the flags for each of those. So for each of those, we just set the 0 flag, set the sign flag, set the parity, and then set the carry flag to 0. Also, I had to do a major refactor. I had all the flags as booleans before, and I realized that wasn't gonna work. In C, you can treat ones and zeros as truthy or falsy. In Swift, you cannot do that. So I just decided to make them all booleans. Turns out it didn't work because I needed to use the carry flag as like a number and like shift it around and stuff. So I changed them back to bytes, or aka 8-bit integers, and set them all to 1. If it's false, set them to 0. So I had to go through and refactor a lot of stuff where I was just like setting booleans and then check if it's true, set it to 1. If it's false, set it to 0. But not super important. And then from there, I just did The same thing for exclusive OR here. And then complement or compare. This is compare, which is just subtracting a register from A. And then setting the flags accordingly. Boom. And then we have complement, which just flips the bit using this notation. We can do that for the carry flag as well. Down here we have rotate instructions, and what rotate instructions do is just take every bit and move them over one spot. This is useful for multiplication and division. The 8080 processor doesn't have multiplication instructions built in, so it does multiplication by just shifting the bits. So, for example, say you have the number 1 in a 4-bit number, so that would be 0001 in binary. If you shift all the bits over 1, that becomes 0010. Follow me? What'd you just do? By shifting the bits over, you just doubled it. And then if you shift it again, it becomes, well, yeah, because 0010 is 2 in decimal notation. And then if you move it over again, it's 0100. What does that equal? That equals 4. And you just doubled again. Move it over again. 1000, that's 8. And you just doubled it again. So that's how you implement multiplication. And if you wanted to divide, you just move it back the other way. So just a little inside baseball. Inside computer processing unit. Anyway, and then this last one just sets the carry flag to 1. And that's pretty much all I did in the last video. Seems like not much when you go over it this fast, unfortunately. But the code will be in the description. Yeah, since I'm here though, let's actually start implementing more stuff. Other than that, do not have all pad. Actually, yeah, I can just use it. Do stuff on. I can do stuff on my computer instead of my iPad. Not important. All right, so let's pull up the documentation again. The next group I have is the IO and special group. IO standing for input output. So in this case, it would be like a controller, but IO could also be anything from a mouse, keyboard, printer, anything that interacts with the outside world. So let's see, how do we implement these things? These are instructions that don't fit into any other categories. I'll mention them for completeness, but I think we're going to have to revisit the implementation when we start to emulate the Space Invaders hardware. Okay, so guess we're not implementing that now. I should have read this before I started recording, but I don't know. That's just how your boy do. Okay, so alright, so there's interrupts. There are serial, IO. There's a halt, which means to stop execution. There's in and out instructions that talk to external hardware. And then there's no op for no operation, which means don't do anything. Yeah. Okay, so we're just gonna move on to the stat group then. Actually, let me move this over here so you can actually see what the heck I'm reading. So the stat group, can I make this bigger? Yeah. Okay. All right, stat group. So, go back and read the stack section. I don't need to read nothing. I know what a stack is. God dang it. Let's actually look just to be sure. I don't want to read all this. This is not. I don't need this. I'll be fine. Watch, I don't be fine. All right. Anyway, so let's take a look. Push and pop only work on registered pairs. Push puts a registered pair on the stack. Pop takes 2 bytes off the stack and then puts them into a registered pair. Therefore, push and pop opcodes for each register pair. Okay. Okay, so, alright, this is just some examples on how to do push and pop for certain registers. This seems pretty straightforward. So, let's go ahead and start implementing this. I'm gonna again create helper functions rather than just implementing it in my giant switch statement. So we're gonna do function pop register 1. I don't actually know how I should do this though. 2 is uint 8. So, okay, so okay, so this stuff is just a matter of, okay, I think I might, for now, I'm actually just gonna do individual functions for each one and see if I can refactor it later to have more code reuse. At the moment, nothing's jumping out of me as a way to specifically generalize this, just because we have this instance variable state, so I'm a little bit confused about how I would generalize it at the moment. I'm sure there's a way, but there's no need to prematurely optimize at the moment. Okay, so it's pretty easy to implement pop. All you're doing is grabbing the top two values on the stack. Quick explanation on how a stack works. Think of it as like a literal stack. So boom, 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 boom. Imagine these are numbers. Boom. For a stack, it is first in, first out. No, last in, first out, I think. So like if you stack things up, the thing on the top is the only thing accessible. So when you push something, you put it on the top. That is the last thing added. And then that is called a push. When you pop, it removes the last thing you added. So last in, first out. Boom. So whatever's at the top of the stack, that is the only thing accessible. So if you pop something, it's going to be the last thing you put on the stack. All right. Think of a stack of pancakes. Pancakes. Yummy. So you're cooking pancakes, right? You get good, like, I don't know, three 3 flapjacks. Think you got 3 flapjacks. And you're going to eat them one at a time. You're not going to go and get the bottom flapjack. You're going to eat the top flapjack first. And what is the top flapjack? It's the last flapjack made because it's on the top. Got it? Good. Woo. I've never had a teacher explain stacks like that as pancakes. And I don't really know why. I feel like that's actually a pretty good way of explaining it. It's almost like I could have been a teacher. Okay, so anyway, for push, it's just gonna be the opposite. So we're gonna take state that stack pointer. Oops, I need a space there. Okay, so we're gonna say okay, so we're gonna take 1 minus the top of the stack. We're gonna take B, set it to 1 minus the top of the stack, and then we're gonna say take that memory. Yeah, and then the stack pointer minus 2 is C, and then the stack pointer it'll be minus equals 2 because we added these two we added the 2 things to the top of the stack, so we have to move the stack pointer down too. That makes sense? Cool. I hope so. Yeah, all we're doing is putting things on memory inside the memory array. And then the stack pointer is just like where on the stack the top is pointed to. We don't actually have to manipulate memory itself. We just have to move the stack pointer around. As like things are popped off, we move the stack pointer. But if say we add something where something already is, it's just gonna automatically be overridden, so you don't have to worry too much about it. Like the stack pointer pointing to the wrong place or having like garbage memory. As long as the stack pointer knows where the top of the stack is, it's not a big deal about what's in the stack. Okay, so they also implemented the PSW, but I'm actually gonna implement the 2 other register pairs. It's just gonna be very similar to the other one. So pop D. Yeah, so it's gonna be that, and then pop push in D. Let's see. I just thought about pushing P from that. Thug is free! Woo! Yay! Yeah, free YSL. Maybe him and Gunna can be friends again. I doubt it, though. I don't know. A girl can dream. Alright, so we're just gonna do also H. The robots know what I'm thinking. Alright. And then push H is. Okay, so yeah, these just operate on the what's it called? The D and E register for D, and then H operates on the H and L registers. Pretty simple. And then now we have to operate on a special register called the PSW. So pop P. I almost said pop in P word. Went as P word. I'm trying not to, well, not get demonetized, but not get age restricted. So I'm not gonna say that. But it's funny. All right, let's see. Pop P. So this one has to set a bunch of flags. Alright, I'm bringing the tutorial back on the screen. This is so much better of a format than what I was doing before. But, you know, you live and you learn. I'm so stupid. Alright, anyway. So, yeah, for PSW, that is a special registered pair of the accumulator and the condition flags. So it's going to affect a bunch of condition codes. So to implement that, we're just going to set state.a equal memory at the offset of the stack pointer +1. And then we're gonna create a new variable called PSW, and that's gonna be equal to where the stack pointer is currently. And then we're gonna say, let's see, yeah, the zero flag is equal to 1. If it's equal to PSW ANDed with 0.01. And then because this is not a Boolean, we gotta say, gotta use the ternary operator to check if it's true or false. If it's true, it will be set to 1. If it's false, it'll be set to 0. And then these kind of follow the same kind of structure. So I'm just gonna copy and paste real quick. Set this to S. This is P. This is a carry. And then he actually also implemented the auxiliary carry, which is something we have not kind of bothered with so far, just because Space Invaders does not use the auxiliary carry. Okay, so for sign we're checking 2, for parity we're checking 4, for carry we're checking 5. 5 and 8. I don't know what this code is doing. I'm literally just translating it from C to Swift, hoping things work. I'm sure it works. Honestly, sometimes with programming, you just kind of gotta steal some code and hope it works. This is why we write unit tests. This is why we would write unit tests if we were smart. Okay, now we're pushing P, aka pushing positivity. So glad. Young, truly humble under God is free. Thank you, Jesus. Okay, so for this one, we're just gonna subtract 1 from the stack pointer, set A to that. We're gonna let PSW equal so it's gonna do this, but No, that's not correct. The robot's wrong. We're gonna do this. And I shifted it the wrong way. Alright, let me get this typed in and I'll explain. Okay, so what are we doing here? We are just combining all the flags together. So, first spot, we put the 0 flag. Second spot, we put the S flag. We're shifting it over left 1 bit, I believe. Shifting this one over 2 bits. Shifting this one over 3 bits. Shifting this over 4 bits. So, for example, if so this would be like a 5-bit number. So we have 5 spots. Say 0, the 0 flag is 1, the sign flag is 2, P flag is 3, carry flag is 4, auxiliary carry flag is 5. We're gonna have each of those spots, and then the 1 for the 0 flag will be in the first spot, the 2 for the sign flag will be in the second spot, the 3 for the parity flag will be in the third spot, the 4 for the carry flag will be in the fourth spot, and then the 5 for the auxiliary carry will be in the 5 spot. That way you can use that to check if to like store them in one number. It'll make it a lot easier to operate on. Okay, so and then the next step is we set the memory. We set the whatever's on the 2 below the stack pointer PSW, and then we set the stack pointer equal to the stack pointer minus 2. Oh, this should be just whatever. Let's just do that. Okay, cool. Those are done. And then there's 2 more instructions that we need to implement. There's SPHL, and that moves the HL register pair in to the stack pointer, so thus moving the stack pointer's address. So to do that, we're just gonna do SPHL. Let's say let HL equal HL, and then state dot stack pointer equals HL. I think that's all we gotta do. That AI what AI just suggested, I think might, I don't know if it's completely necessary. It said to change the orientation. So quick thing that also just popped in my head. Bits in CPUs can be organized in 2 separate ways. So when you have like a high and a low bit for like a 16-bit register, they can be arranged in two different ways. There is big Indian form and little Indian I don't know actually how it's Indian with an E. I'll put up some stuff to explain it, but basically that says like whether the low bit comes first in there or if the high bit comes first. So some CPUs use little Indian form, some CPUs use big Indian form. I believe I don't have to convert it because my my high-low or HL helper function is already taking that into account. So yeah, I am moving the high bit over, so I believe it'll be consistent. All that matters is that you follow the convention of the CPU that you are trying to emulate. All right, cool. Got it. You're not confused, right? Because I'm not either. All right, anyway, so, and then there's one more. There is XTHL. Exchanges whatever's the top of the stack with whatever is the HL pair. The instructions say, why would you want to do that? I don't know. Okay. But we're still going to implement it. I'm sure there is a reason, right, to do that. Alright, so exchange whatever is the top of the stack. So let HL equal HL, let SP equal stay dot SP, and then dot SP equals HL, stay dot memory. What is this dot byte swap shit? Oh, okay. So we gotta I don't know what the fuck I'm doing right now. All right, so okay. I think I know some of what's going on, but not completely. So we're gonna have to grab the book. Oh, okay. So I apologize if this is like kind of hard to see. It's like somebody literally photocopied this book and saved it as a PDF, but hopefully it is usable. So where are we at? Instruction set. We're looking at the F group. Yeah. What group are we looking at again? Not data transfer group. Not the arithmetic group. Nah, not the logical group. Not the branch group. There we go. No, not the IO group. Wait, yes, stack. Yeah, so, alright, we did those. Yeah, here we go. So, exchange top of the stack. The content of the L register is exchanged with the content of the memory address, which is specified in the content of the content. One more than the content. Okay. Oh, okay. That's not too hard. All right. So I I don't believe I can use this helper function, though. So H equals, H, L equal L, God damn it. This is really annoying. Alright. And then stack pointer set to that. Yeah, I just want to put these in local variables just so we're not getting we're not like having race conditions or something. Okay, so well, not race conditions, but as I'm changing things around, I don't want there to be whatever. I'm just gonna edit this out. You get what I'm doing. I don't want them to change when they're getting swapped around. All right. Anyway, let's see. So we have so that means, oh yeah, first we're gonna say yeah, sp1 equals mem, and then sp2 equals state memory plus 1. Okay, state.memory equals L, H equals 1 plus memory, and then no, what? I don't know what this last part is for. All right, so we got state.memory. Okay, we're set here. And then let me take a look at the book. Time. Oh, okay. And then yeah, and then we just have to say state dot H use sp1 state. No, that should be sp2. State.l equals sp1. Okay. Here's what we're doing. Up here, we're setting a local variable h to the content of h, local variable L to content of L, setting creating a local variable sp1 for stack pointer value 1 to the value of what's on memory at the stack pointer, and then sp2 to 1 above the stack pointer. Follow me? And then we are setting the state.memory where the stack pointer is. We're setting it to L. We're setting 1 plus the stack pointer to H. And then we are setting L to stack pointer 1, setting H to stack pointer 2. All we're doing, swapping H and L with the top stack pointer, the top 16 bits of the stack. Okay. All right, now that we have this done, we have to use these helper methods that we just created. So, as you can see, we have the big instruction list here. I'm not going to have this here, though. I'm going to have it off to the side. Cool. So, we are going to add these to the big list. I didn't mention earlier, all those helper functions, I just added them to the big switch statement. That's what an emulator is. This is a big switch statement. Anyway, all right, let's take a look. So, I always forget immediately what the names of the things I did. Oh yeah, pop B, push B. All right, where's pop B is C1. Excuse me. Let me take a drink of water. My friends and I love to abbreviate things for no reason. So I wasn't here for this, but my friends went and saw like a outdoor concert once. And so when we're together, we never say full words because we think it's funny. So my friend Julius, I don't know if I've ever heard him say the word water. He always abbreviates to WA. Abbreviates it to WA. But like a normal person, if he was to say WA to them, they would have no idea what he's talking about. So at this outdoor concert on a really hot summer day, a guy actually passed out. And as they were, people were asking for help, the crowd goes silent, and Julius yells, "Somebody come get this guy some wah." And my friends told me they were just like mortified that he abbreviated water. Like, no one knows what wah is. Hopefully they used the context clues. I wish I was there, but my friend Julius is a treasure. Anyway, C1. So it will be, here we go, right to here. Case. I think I could probably just fast forward to this through this part. So I'm just gonna do this. Probably not gonna talk because it's kind of self-explanatory what I'm doing, and it's boring. We are actually good to move on to the next section. Okay, so as far as this video, I think I'm gonna call it here, and I will continue to implement different things in the next video. But as always, thank you for watching. Please like and subscribe. I forgot to say it at the beginning. I'm becoming a better YouTuber. Hopefully the audio won't be off again. I heard the comments. I will try to do better as far as technical things. I think I have figured it out. If not, I don't know what to say. Also, I forgot to even do this. I have sound effects too. So hopefully I'll remember to use them next time. But anyway, thank you so much for watching. I'm Maddie. This has been another Code and Vibe Code and Vibe Sesh. I will see you guys next time. Hopefully soon. Probably in about a week, maybe sooner. We'll see. Try and be a real YouTuber. Anyway, please like and subscribe. Thank you for watching. Bye bye.